Today, welcome, by the way, welcome. Today we're going to talk about math. It's going to be a good time. We're going to talk about finding the percent of a number, and that's all about proportional relationships. And I'm real excited to do so. What do you call a person who draws animations on vehicles? Well, they're called cartoonists. Did you hear me say car? Cartoonists? Okay, today we're going to estimate and determine the percentage of a given number, given whole number, including but not limited to benchmark percentages. And once again, we're diving into the thingy thang. Thingy thang is a tool that works with proportional relationships, but we want to make sure we always know how proportional relationships work before we dive into that. So just a reminder, proportional relationships have two variables where their ratios are equivalent, okay? For example, 2/3 and 6/9. So I don't want to say 2/3, 2 to 3 as compared to 6 to 9. Are they equivalent? Well, if you set up the ratios as fractions and you set them equal to each other and they become equivalent fractions, then yes, it is equivalent. So this one went up by the rate of 3 on the top and bottom. So just like equivalent fractions, if the top and bottom are multiplied or divided by the same thing, and I said multiplied or divided by the same thing, then they are equivalent, which in this case means they are proportional. But if you have two fractions where they are not equivalent, in other words, I multiplied the top by 4 and I multiplied the bottom by 3.2, then that tells us, they are not equivalent, and which means that these are not a proportional relationship. Okay, so setting up proportions, the same thing, percent proportions, is all about comparing two ratios. And sometimes when we compare ratios, we talk about parts of something compared to the whole something. So percents are part of a whole, right? So if you ate 37% of a pizza, you ate part of the pizza. If you ate 87% of the pizza, you ate 87% of the pizza. And we know that 100% would be the whole, right? If I said I earned 100% of the money, I earned the whole stack of money. If I had to read a book and I said I read 100% of the book, I read the whole book. So percents are part of a whole. And the other thing we know about percents is whenever we say a percent, like 37%, if we wanted to take 37% and make it a fraction, what it really means is 37 out of 100. The part is 37 out of 100 being the whole. Okay, so remember how we set up the portions using parts and wholes? Remember when we did this back in understanding how to solve proportional relationships? We said it's all about the labels. If I put the part and whole on one side, I have to set it equal to the part and whole on the other side. Super important stuff, right? In other words, if I had two parts, let's say there was 2 kids that finished their math test out of 20, which was the whole math class, I could say that would be equal to, if there were 80 kids taking the math test, how many would be done at this point if we were to stay in proportion, right? So we put 20 was the whole class and 80 was the whole group if we imagined a bigger group. And then the 2 and the X were the parts of the classes, parts of the whole classes that finished the test. So parts over whole. Okay, and this could have been flipped over. I could have put whole over part and whole over part. All right, so now let's see what that looks like when we're finding percent of a number. Okay, so part of a whole. What did we say up at the top of this slide that was a part? Well, a percent is a part of a whole. Okay, and we're going to set it equal to part of a whole. So a percent would go on top. So a percent is a part. And remember, a percent out of a whole is always out of what? It's always out of 100. So that's our initial ratio, or that's our proportion on one side. We take whatever percent we have and we put it over 100 because every percent is a part and 100 would be the whole when we're dealing with percents. Okay, this could have also been flipped over. I could have put 100 over a percent, and on the other side I could put whole over part. It doesn't matter as long as your labels are lined up correctly. Okay, now we just need to figure out the other side of the proportion. So let's see what we're talking about here. Let's review that thingy thang. Okay, when we're finding a percent of a number, we know that we are using proportions to represent percent. So percent, this is part of the whole value. 100%, this is the whole value of a scenario. All right, so if I said I had 82% of the M&Ms that were delivered to the class, that means out of the whole group, I had 87%. And the whole group would be all the M&Ms together, okay? And percent over 100, this is our initial ratio. So if we know what our initial ratio is, and we understand how proportional relationships work, right? Which means whatever we do to the top, we have to do to the bottom through multiplication or division. And we know the initial ratio is going to be percent over 100. Then we get to use this amazing tool called the thingy thing. That's right. So let's take a look at this one, okay? So 20% of the students in the band were part of the drum line. There are 18 students in the drum line. What is the total number of students in the band? Okay, so here is our situation. We have part over whole equals part over whole. That's how we're setting up our proportions. We're dealing with percent of a number. So now we need to go back and try to figure out how we're going to fill out this situation, okay? So here we go. Now we need to go look and look for clues. So this top portion right there was just based on reminding you on how part over whole equals part over whole. Now we're going to use the scenario at the bottom to figure out how to solve this, okay? So first thing first, one of the clues is 20% of the students in the band were part of the drum line. So we know that part of the band was in the drum line, and that's 20%. So we can go ahead and put that where the percent is. We can leave 100 at the bottom because 20% is always 20 out of 100, something out of 100, so that's fine. Now we need to figure out how to do the other side. There are 18 students in the drum line, and our other clue is students in the band. We are comparing the drum line to the whole band. So again, the 20% was the 20% of the drum line, and we know that 100 represents the whole band. And 18 represents the students in the drum line, so that's going to go on top. And students in the band is what we don't know, so that becomes our variable. And now we've got ourselves a thingy thing, don't we? We got a proportional relationship set up where our labels are correctly lined up. On the top, we have the drum line, and on the bottom, we have the whole band. Part over whole. Okay, so now that we have that, let's go ahead and think about solving it. Step one would be to set up the proportion correctly, which we did. And then we're going to cross multiply, and then we're going to set them equal to each other. I'm kind of going through this fast because it's been in our last 4 or 5 videos. And finally, divide both sides by the coefficient. Let's break that down and do it a little slower now. Here's our scenario. We decided that this would be our proportion. Okay, so step one, set up the proportion correctly. So that was our percent over whole, 20 over 100. And on the other side, since 20 represent 20% of the drum line, we knew that 18 represented the students in the drum line. So drum line's on top and the whole band's on the bottom. So now we've got our proportional relationship. How do we solve it? We cross multiply. We take the top of one and multiply it by the bottom of the other. 20 times B equals 20B. And then we do the other one. 18 times 100 equals 1800. So we've done step 2. Step 3 tells us to set them equal to each other. So whatever your 2 answers were, just go ahead and set them equal to each other. So we have 20B and we have 1800. So what we have is 20B equals 1800. And the final step is divide both sides by the coefficient. The coefficient is the number that's touching the variable, and that would be 20. So we're going to divide both sides by 20. And remember that 20 divided by 20 is going to cancel out and make 1B, which that means one side is going to be B. And then 1800 divided by 20 gives us 90. So that B represents 90. And what was the B all about anyway? Well, it's the answer to our problem, which was what is the total number of students in the band? There are 90 students in the band, and 18 of them are in the drum line. All right, so hopefully that makes sense to you guys. All you got to do, remember, it's the thingy thing. If you can figure out how to set up your proportion, get your initial ratio figured out. In this case, it's percent over 100. What percent are we talking about? And then you just got to find out, what am I trying to find? Am I trying to find the whole, or am I trying to find the part on the other side? In this instance, we were trying to find the whole because we knew that part of the band was the drummers. The key to percent problems is knowing the percent involved, which is our initial ratio. So when we know our percent, we can put it over 100, which will be our initial ratio. Sometimes you have to actually solve the percent, so the other side will be the initial ratio, but it doesn't matter in the thingy thing. You fill out what you know, and then you cross multiply and divide, right? But in this instance, at this point in your math career, you're probably going to be given the percent every time. So we need to know the percent involved. Then we can use the world's greatest tool, which is the thingy thing, right? Use the percent involved. So on one side, we're going to have percent involved. Let's say it was 37%. So it'd be 37 over 100. And that would be our initial ratio with the thingy thing model. And then finally, once we have the initial ratio, and we on the other side, we know what's missing, we cross multiply and divide to find the missing measurement. Isn't this exciting? It's so exciting. What did the jack say to the car? Can you give me a lift? That's what jacks do. They lift the car up.